So we've looked at two types of limits. Type 1, we plug it in. Type 2 limits, we factor it first and then we plug it in. Okay, let's go with type 3. Okay, so type 3 limits are kind of like the clowns. All right, the clowns. Type 3 limits are going to infinity or negative infinity. All right, so within the type 3 limits, there's 3 different groups. The first group, we have the highest power that is in the denominator. Okay, so you can look at the graph. As this graph goes way, way out there to positive infinity, or way, way out there to negative infinity, it is approaching what? You may be able to see from the graph that it's approaching 0. Okay. However, if you don't have a graph, I know that it's approaching 0. Why? I got my little mnemonic device. The clowns, or the bilingual Spanish speakers, the silly BOBO. What does BOBO stand for? Bigger on the bottom, 0. What's bigger on the bottom? The degree. No, you're right. It is the exponent, but we're looking at the degree. Okay. Why is it going to 0? Well, here's why. Okay, so let me explain it to you. Let's say I plug in 10 for x. Then I've got 3 over 100. Let's say that I plug in 1,000. Then I would square 1,000 and divide that into 3. Let's say I plug in 1,000,000. And then I would square 1,000,000. So what's happening? The denominator is getting bigger and bigger and bigger. And what's happening to the fraction? It's getting smaller and smaller and smaller. Therefore, it is approaching 0. Okay, so here we have the limit as x goes to plus or minus infinity. My degree of the numerator is 1. The degree of the denominator is 2. Therefore, it's bigger on the bottom. Therefore, the value of the limit is 0. Okay, that's the first group. The next group, we have the highest power is, let's say it is the same. Okay, and so this is what I call it. It's the same in the numerator and the denominator. So I call this Bosco. Bosco, meaning both of them are the same. It is the, I was setting you up there. That was your key. It's the coefficients. All right. So I'm looking at the degree of the numerator, which is 1. The degree of the denominator is also 1. Therefore, what is the value of the coefficient? 3/4. Okay, and over here, careful, right? The value of the coefficients is 5 over negative 3. Just be careful with the negative sign. Okay, but I was waiting for somebody to ask me, let's go back. I want to go back and touch on this. I was waiting for somebody to say, but Newhouse, what about the +7? Well, the +7 doesn't matter. Okay, and so let me try and explain to you why it doesn't matter, why we only look at the degree. Okay, we're talking about going to infinity. So it's kind of like saying, are we in this classroom closer to the sun than people on the first floor? Well, I guess technically, yes, but does that really matter? If we're millions and millions and millions of miles away? No, it doesn't. If you spit in the ocean, does it change the volume of the ocean? Well, I guess technically maybe, but does that really matter? No. Therefore, the plus 7 doesn't matter. Okay, we're only looking at the degree of the polynomials in the numerator and the denominator. Okay, so if it's bigger on the bottom, it's going to 0. If both of them are the same, then we look at the coefficients. And if the highest power is in the top on the numerator, then what? Well, it has to be one of two things. It's either going to positive infinity or negative infinity. Okay. Here's my little mnemonic device. You probably haven't heard this, but that's okay. But no ha. But no ha. Which means what? Bigger on the top, and there is no horizontal asymptote. Bigger on the top, no horizontal asymptote. Okay, so look at the graph here for the first one. All right, I have 5x squared plus 1 over x, and this is going to positive infinity. And so if you look at the graph of the function, this function is going way, way out to positive infinity. And so here's the first thing that I want to say. If it's bigger on the top, then it's either going to positive infinity or negative infinity. Those are the only two options. All right. In this case, you can look at it, and as it goes out this way, this is going to positive infinity. Yes. I can look at this one. As the function goes to negative infinity out here, this function goes way, way out. It's going to negative infinity. But how do you tell, hypothetically speaking, if you don't have a graph? Oh no. What do we do? Well, like, where'd the graph go on B? Well, let's just decide to leave it out. How do we do it? Do we throw up our hands in despair and run away from our problems? No, I say we face them head on. How do we do this? I'm okay with awkward silences. I can outweight you. I'm stuck. You got to help me out. Well, here's what you do. How about I help you out? It's either positive infinity or negative infinity. And so we look at the side. If this is the limit as x goes to infinity, I'm plugging in positive numbers, right? Because it's going to positive infinity. Okay. And so my numerator here, this is squared, which means it must be positive. But then I multiply it by a negative 0.05, meaning that my numerator is going to be negative if I plug in a really large positive number. If I plug in a really large positive number in the denominator, it's going to be positive. I have a negative over a positive, therefore, this is a negative infinity. Okay, well, look at this one. This time, this is going to negative infinity. Therefore, I'm plugging in negative numbers. So same thing. It's squared, positive, but then it's multiplied by a negative, so that makes that negative. The denominator, I'm plugging in negative numbers, so that's going to be negative. Therefore, this has to be positive infinity because I have a negative over a negative. Okay, stop right there. Look at the first page. Make sure that you understand it. If you don't, ask me something now. This, okay, that's a good question, and I'm going to bring that in just a second. But that means bigger on the top, no horizontal asymptote. Okay, there is no horizontal asymptote because look at this. Look at the graph. Is there a horizontal asymptote for this function? There's not a horizontal asymptote. There is a slant. or an oblique asymptote there, but not a horizontal asymptote. Yes.
Is the Bosco one?
Both of them the same coefficients. Both of them the same coefficients. The mnemonic device, I don't care what you use, just get it right. Right? All right, here we go, page 2. Page 2, A, B, and C. Do those for me right now, okay? Check your answers with your friendly calculus neighbor there. See how he or she is doing. All right, here we go. The limit as x goes to infinity of 3x plus 8 over 4 minus 7x. What's the value of the limit? 3 or negative 7. What about this one? Bigger on the bottom, 0. What about this one? It's either positive infinity or negative infinity because it's bigger on the top. Okay, which one is it? The numerator has to be positive because it's raised to the 4th power, which is even. Right? And the denominator has to be negative because I'm plugging in negative numbers and it's raised to the 3rd power. Therefore, this will be negative infinity. Okay, so let me stop right there and make a little clarification. Because you may be like, okay, got it. But I promise you, when I give you one of these 3 months from now on a little calculus test, you're going to forget this. This only works. We only do the Bobo, the Bosco, and the Banoha only if it's going to infinity. If it's going to a point, if it's the limit as x goes to 1, or it's the limit as x goes to 0, we check to see if it will factor. And then we plug in. Or if it won't factor, we just plug it in. But we do this only for limits going to infinity. Got it? Yes. No, they will not. All right, here we go. Vertical asymptotes versus discontinuity. How do we find a vertical asymptote? Well, let me give you a quick example. This has a vertical asymptote. I hope that you can recognize that it does. Where's my vertical asymptote? It's at x is equal to 1. Right? How did I get that? Do I just know? Well, what happens if I plug in 1 for x? My denominator is 0, and therefore it is undefined. Therefore, I have to have a vertical asymptote at x is equal to 1. Okay, so to find vertical asymptotes, we're going to set the denominator equal to 0 and solve. Okay, so example 1 says, find the vertical asymptotes. I have a graph here. I can tell that there's a vertical asymptote at x is equal to -1. Everybody see that on the graph? All right, so let's work it out here. I have an x minus 4 over, I'm going to factor the bottom, x minus 4, x plus 1. What happens to the x minus 4s? They cancel, meaning I have a removable discontinuity, right? I said that previously. Okay, so there's a removable discontinuity at 4, right? And I'm going to have a vertical asymptote at x equals -1. Okay, there's still a 1 there. Because if I plug in -1, I've got -1 plus 1, which gives me a 0 in the denominator. Okay, so second example here, I'm going to factor the numerator. So I'm going to take out a 2. So that gives me x plus 3. Then I'm going to factor the bottom. So I've got x plus 3, x minus 3. And again, if it factors out, that means there's a removable discontinuity there. And then I'm left with 2 over x minus 3, meaning I have a vertical asymptote at x is equal to 3. All right, so those are vertical asymptotes. How do I find the horizontal asymptote? I gave you a little clue. What's the mnemonic device for the third thing? Bailey, you asked me. It's
Bigger on top, no horizontal.
but no ha, baby. Okay, bigger on top, no horizontal asymptote. There's no horizontal asymptote because it's going to infinity or negative infinity. So to find the horizontal asymptotes, I'm going to find the limit as x goes to plus or minus infinity. That's why we were doing these. Okay. When I find the limit as it goes to infinity or negative infinity, I'm finding the horizontal asymptote. Okay, so this says find the horizontal asymptote for f of x is equal to x minus 4 over 3x minus 4. So I'm going to look at this. The degree in the numerator is 1. The degree in the denominator is also 1. Those are the same. So I'm going to look at the coefficients. So what's the answer? Actually, it's not. This is wrong. Why is it wrong, Newhouse? Well, because Newhouse did not answer the question. What is the question? Find the horizontal asymptotes. So this is what you were telling me. You were telling me there is a horizontal asymptote at the point 1/3. No. Horizontal asymptote is a line, right? So what do I need? Not x equals, but y equals 1/3. Do I know what you mean? Yes. Am I going to count it wrong? Yes. But you knew what I mean, Newhouse? Well, that's a good point because the AP reader can read your mind when they're grading the question. No, it's wrong. I might, out of the generosity and the goodness of my heart, give you partial credit. But if it says find the horizontal asymptote, don't give me a point. Got it? Got it. Well, let's look at this. Find the horizontal asymptote. F of x is equal to x plus 2 over 3x plus 2. Okay, so I'm going to look at the value of the coefficients. And I get y is equal to 1/3. F of x is equal to x cubed plus 5x minus 7 over x plus 1. And this is but no ha. No ha. Which means there's no horizontal, so don't write 0, right, or something like that. No horizontal asymptote. Don't look, I'm on a roll. Part C, if the horizontal asymptote is y is equal to 4, find the value of a for f of x equal to 8x squared minus 3 over 8x squared. What is the value of a? Well, help me out here. How did we get 2? We're correct. Okay, it is 2. But the degree is the same, 2 and 2, which means I'm looking at the coefficients. So I know it's got to be 8 over a, and that's equal to the value of the horizontal asymptote, which is the value of the limit, which is 4. Therefore, a equals 2. Okay. Questions for me? Make sure that we are all on board the calculus train. I don't want anybody standing at the platform waving goodbye as the calculus train leaves the station. I have a lot of metaphors. We all good? All right. Here we go. Example number 3. Find the one-sided limits. What? Without a calculator? Newhouse. Really? Come on. I mean, here's a I know it's early, but a philosophical question. Was there any math done before the invention of the TI-84? I mean, when I went to school, I don't even know that I even had math because there was no TI-84 back in my day. Old man yelling at you, get off my lawn here, okay? How do we even do this without a calculator? I guess we'll just throw up our hands in despair and run away from our problem. Yes?
You plug in the.
I really appreciate you just trying to answer my question because everybody else is just like, oh, well, here's how you do it. Let's look at it. We have the limit as x goes to 1. From the negative side, it's one-sided. And what do we notice? What's happening at 1 in this function? There is a what? There's a discontinuity. What type? There's a, let me out. There's a vertical asymptote at 1. Okay. So here's what we're going to do. I'm going to plug in a value and check the sign. Okay. If there's a vertical asymptote here, that means that the function is either going to positive infinity or negative infinity. So again, I'm going to plug in a value and check the sign. Well, which value? Well, it depends. Okay. It is approaching 1 from the negative side. So I'm going to plug in a value on the left-hand side of 1 that is close to 1 and check the sign. In this case, I'm going to plug in 1/2. So I'm going to put myself a little note here, a number close to 1 from the left. Okay, so let's say that I plug in 1/2. Why 1/2? Because it's getting close to 1 and 1/2 is on the left side of 1. So first thing I'm going to do is eliminate that because that doesn't matter. It doesn't matter because it's squared. Therefore, it has to be positive. And so I don't care about that. All you're checking is the sign. So if I plug in 1/2, I have this. -3 times 1/2 is negative. I don't even care what the number is. All I care about is the sign. Then I have 1/2 minus 1. That is also negative. So I've got negative over negative. Therefore, this has to be approaching positive infinity as it gets closer to the asymptote. Well, this is the same problem. I'm just approaching it from the other side. Okay, so this time I'm going to plug in, let's say 1.5. Because 1.5 is on the right of 1. And again, the x squared doesn't matter. So I've got -3 times 1.5 over 1.5 minus 1. All right. And so I've got -3 times 1.5. That's going to give me a negative on the top. And 1.5 minus 1 is going to give me a positive on the bottom. Negative over a positive. Therefore, this is going to negative infinity. And one more here. Okay, this is the limit as x goes to 2 from the negative side. Okay, so I've got -1 over x minus 2 squared. There's an asymptote at 2, a vertical asymptote at 2. Therefore, my function is going to be approaching positive or negative infinity. Which one is it? It's approaching 2 from the negative side. Okay, but actually I don't need to do that in this case because the numerator is always negative. Yes, it's always -1. So it's negative. What about the denominator? It's always positive because it is squared. Negative over positive, therefore, this has to be negative infinity. Okay, so take a look at that page. And let me know if you have any questions on that I can answer. Don't be afraid to ask. Yes.
Why did you get rid of the x squared in the first place?
Okay, all I care about is the sign. Okay. But it does not really matter there because it's squared and it's going to be positive. Okay. It would. Okay. Because then, depending on what number I'm plugging in, it could be positive or negative. Okay. All right. Well, I have a little guided practice for you. Turn the page there. And there should be